Well, we introduced a iDriver product for industrial application to drive IGBTs several years ago. What happened was that caught the attention of automotive customers, and so they came to us and said, would you be able to do an automotive version of that? And we got so much interest, we made a commitment to move into that market, which is not, by the way, is not a small commitment because it takes a lot of money and resources to get into the automotive market, and it's a very long-term market. It takes many years before you get revenue. But as a company, we decided to do that because of the pull we were seeing in the marketplace. And that market is changing as we speak. There are a lot of changes happening. For example, they're going from 400 volts to 800 volt batteries. They're also going from IGBTs to silicon carbide. And the reason they're going to silicon carbide is because silicon carbide is more efficient, it produces less heat, and therefore the inverters get much smaller. Now that's a huge advantage in mobile applications. So even though the silicon carbide is slightly more expensive, actually quite a bit more expensive, you can easily justify that in a mobile application, which you can't do it in a static application. So they came to us and say, hey, we would like a driver specific to silicon carbide. Now you may ask, why is it different from an IGBT driver? Well, there are many differences. First of all, IGBT has a lot of thermal mass. It's a very, very large device for a given current compared to silicon carbide, which is a very tiny die size. And because of that, you have the challenge of having to turn the silicon carbide off very quickly so that it doesn't get damaged when you have a fault condition, like a short circuit, for example. Now, you may say, what's the big deal? You can turn it off very quickly. Unfortunately, the faster you turn off, you have the higher risk that you have a transient voltage that could destroy the transistor. So turning it off fast is the easy part, but turning it off safely is much harder. So we not only have to turn it off fast, we have to make sure that while we are turning it off, the drain voltage does not exceed the breakdown voltage of the transistor. And we have developed a proprietary technology that continuously monitors the drain voltage and in a closed loop fashion make sure that it never exceeds the the breakdown voltage of the transistor. So that's one challenge. The other challenge is that unlike IGBTs, which always have the same drive voltage, it doesn't matter who you buy the IGBT from, it's plus or minus 15 volts, and therefore you can have a single driver that will drive any IGBT. In case of silicon carbide, because of brand new technology and everybody's transistor is a little bit different, they have different drive voltages. Some people have plus 10, minus 5, some people have plus 12, minus 3. So we have to accommodate that. So we actually have designed the chip so that it can actually adjust to any silicon carbide device you have. You can actually choose any voltage you want, positive and negative. So that's another big advantage. The third one is you just need to be able to switch it faster, so which means you need much higher current to drive it. And we provide 8 amps of current in our driver so that you can switch it at 100 kilohertz or 150 kilohertz, which is a lot faster than IGBTs, which typically run between 2 and 20 kilohertz. So those are the challenges that our drivers overcome. So one of the technologies we offer with our iDrivers is that we use a very rugged isolation scheme which has very high breakdown voltage capability. We call it FluxLink, and this has a breakdown voltage guaranteed up to 8,000 volts, So it has more than enough voltage to handle 800 volt batteries. So that's another advantage we bring. And also this isolation scheme, the FluxLink isolation scheme, is very rugged. Much more rugged than any other type of isolation scheme. Historically, people have used optocouplers, but optocouplers are much more complex devices, and under a fault condition, the isolation may not be maintained. And this is another reason automotive people like our technology. The FluxLink technology and our protection features is what made the automotive companies come to us. And so we are very excited about getting into this market and being a major player in this market.